Okay. Hi, this is the presentation for the paper, an optimized H.266 VVC software decoder on mobile platform. Let me enlarge. As shown in this figure, many new coding tools are added in VVC. With the support for the new coding tools and the new coding features, the new standard is significantly more complex than previous codecs, and more efforts are required for acceleration. So, in this paper, we show our effort on the VVC decoder optimization so that a real-time software decoder is optimized. We can support almost all the CTC tools, including AOF, BDOF, DMVR, and so on. And we can support SCC tools in 420 profile, including IBC, BDPCM. Based on Apple A14 processor, the average decoding speed is 53 FPS for random access and 50 FPS for loaded B when decoding Full HD bitstreams. And the decoding FPS is about 82 FPS for random access and 88 FPS for loaded B when decoding Full HD SCC bitstreams. When multi-thread encoding is enabled, an average of 32 FPS can be achieved when decoding 4K bitstreams. The general explanation can be summarized as parallelism and near acceleration. For the parallelism processing, it includes picture level, CPU level, task level, and sub-CPU level. For example, the picture level parallelism supports decoding multiple layer units at the same time when there is no interdependency. SIMD technology operates on loading multiple data in a single operation. If the internal bit depth is 16 and taking 128 bits SIMD, it can load up to 8 data points at once and can help to accelerate the processing efficiency 8 times when compared with no SIMD optimized system. Also, we use the bit depth temporization to make the decoder can support 8-bit and 10-bit at once in one code base. From this figure, we can see the most time-consuming part in LF is consuming part in our code is LF and interpolation. So besides the general idea of the optimization, I will use these two parts as example to show some acceleration strategy. First, AOF. As we know, AOF is processed using 4x4 blocks. If bit depth is 8, the bit length for two horizontal adjacent blocks with block wise equal to 4 is exactly 128 bit, which can utilize the 108-bit SIMD efficiently. In addition, we use the shuffle processing in word level instead of byte level. For interpolation filter, here I put a table about filter coefficients. You can see only the sample in the middle fraction has 4 8-tab filter coefficients. For fractional precision smaller than 5 or larger than 11, only 7-tab filter is necessary. Also, in addition, we also consider the symmetric characteristic according to the characteristic of this table. Then we can see the experimental result. Test bitstreams are generated by BTM11 reference software under the common test condition with HD and UHD YUV 420 test sequence and 8-bit internal bit depth. For Apple A14 SoC, we can see based on 6 threads parallelism, 4K bitstream can achieve about 30 FPS, and using one thread decoding, 1080p bitstream can be decoded above 30 FPS. For Snapdragon 865 SoC, the the average decoding speed for class B is averagely 26 FPS on single thread and can achieve about to 75 FPS on each thread. From this table, we can see the acceleration ratio with and without NEO is about 3.45 times. Then we can see there is a player that can support real-time decoding. It is based on our decoder. You can see when decoding 1080p bitstream, the FPS is much higher than 30 FPS when using two-threading decoding. That's all. Thank you.